So far, we have been working with basic operations, like addition and subtraction. But what about more complex operations? Let's see how Ruby handles the operator's precedence in an equation or any operation. In your workspace, I will make this bigger. Let's clear our screen. And now in our console, let's enter to the Ruby console, IRB. Inside of IRB, let's make just a more compiled operation, like 2 add 2 per 2 plus 2 times 3. So the majority of the people should think Ruby is gonna add 2 plus 2, it's 4, and 4 times 3, it's gonna be 12. Let's see what happened. Ouch. Now you can see that the result was not what you thought. But what's happening here? What's happening? Right now, what Ruby does is just making an order for each operator. So in this case, Ruby first performed this operation instead of the addition. So 2 times 3, it's 6, plus 2, it's 8. You can try change the order. And it's gonna be the same. So this is how Ruby handles the operator's precedence. First, it's gonna look for the potentiation or the exponent operator. Then it's gonna look for the multiplication and division. Then modulus. So multiplication, division, and modulus in the second level. And lastly, the addition and subtraction. But there is a joker in this game that we can use for our purposes. So in our last example, 3 plus 2 times 3, so we know it's 8 because Ruby is performing the multiplication first. But if we want to tell Ruby performed first the addition, we can add parentheses to the operation. And Ruby knows that if we add parentheses, we're gonna perform first the operation inside of the parentheses. So in this case, it's gonna first add 2 plus 2 and then times 3. And the result is different. It works with any kind of operators. For example, in this case, the potentiation or exponent operator is going to be executed first, and then the multiplication. We can say Ruby perform first the multiplication by adding parentheses. So 3 times 2, 6, 6 exponent 2, 64. Now that you know the operator's precedence, you can try ahead and play with this, adding more complex equations and operators. Another important thing we need to know is the numeric comparators or comparations. Let's say A equals 1 and B equals 2. Then if we wanted to check whether or not these numbers were equal to each other, we could use the double equal comparison operator. If we say A equals B, it should return false. and it does. The next comparison operator is a does not equal operator. This is represented using an exclamation point and the equal sign. This checks to see if the two variables or numbers do not equal each other, and it should return true. And it does, because 1 is not equal to 2. We also have the greater than and less than comparison operators. These check to see whether or not the values are greater than or less than each other. Let's see. A is greater than B. False, but A is less than B. That's true, because A is 1 and B is 2. In addition to just seeing if something is greater than or less than something else, there is also comparison operators for greater than or equal to and less than or equal to. Let's check that out. I'm going to create a third value called C and set that to 2. C equals 2. Now let's see if C is less than equal to B, and it should return truth, because 2 is equal to 2, that's B. But if we also check A less or equal to B, it should return true too. But B is not less. B is not less than or equal to 10, for example. Oh, it is, sorry. B is not greater than or equal to 10. That's false. Finally, there's the combined comparison operator. This is sometimes referred to as the spaceship operator. This will return 0 if the first operand equals the second, 1 if it's greater than the second, and -1 if it's less than. Let's see how that works. Here A is 1 and B is 2. Therefore we get -1 back because the right side is greater than the left side. That we do. If we do this with variable C, we should get back 0, and we do. Finally, another comparison operator we have is a method called EQL with a question mark. This is true if both items are the same time and value. Let's see how that works. If we do a.eql question mark C, we should get back false, because A is not equal to C. But if we do b.eql C, we should get back truth. But the difference of EQL question mark method with double equals or equal to is that EQL also checks for the type of the object that we are trying to compare. So if we create another variable called d equals 2.0, we can see that we in this case have d.class, it's a float, and if we make b that is also 2.class, it's a fixed num. Both are the same value, but their types are different. If we make b.eql d, they have the same value but different types. It's false. That can come in handy when you're writing Ruby programs. And those are the different comparison operators available to us when working with numbers. This is the last video of our stage called Ruby Numbers. The next stage is gonna be dedicated to Ruby Arrays. There is a short quiz for you, don't forget to take it. And as always, follow me on Bashtimbalandia, follow Race Karate at Twitter, follow us on Facebook, always keep an eye on racekarate.com, where we will upload the transcript of this video. And thanks for your support by subscribing to our channel. See you next